Did I just not
I think
create a
the
Dropbox?
last one was supposed to be, I think the last one was supposed to be P, but you made it Q.
But I called it Q in the project.
Yeah.
Okay. So we really are on Q?
Yes.
Okay, and so for everybody who named their project Q because I did, I apologize, call this one Q2, Q and a half, QB. All right, so we're talking about classes. What's a class? It's a collection, well, it's a blueprint for a collection of variables and the functions, which I should call methods, that act on them. That's so important, I'm going to type it for a second time. It's a blueprint for objects that are variables that contain variables and methods that use that data. I'm going to modify it so it says that contain data, parentheses, variables, and methods that use that data. For example, a class of books. Class book might have several things, right? Might have a title, might have a, and I'm not, you don't have to be typing along here, you know, and it might have an author, and it might have, you know, a number of pages and other things, right? ISBN number, publication date, publisher, you know, edition, all sorts of stuff. Just an example, right? You know, a class named patient. You know, might have a first name, a middle name, a last name, you know, an address, a birth date, and so on, right? Et cetera, et cetera, et cetera. So it's got these chunks of data in it. Now, if we were actually going to turn these into classes, we have to be giving them, you know, data types, right? Like title and author might be strings, right? Pages might be an int. All of these things to me look like they would need to be strings, not sting. Right. Semicolons after everything, and so on. They also have methods. Methods are functions that use that data. Hey, Parker. Like, we might want to print the information of the book, right? Might want to be able to print that stuff out. Print, right? And then it would have some code in it inside some curly braces. Now, anytime you have a function, a method, you have to give it a return type. Right? Same for the patient, right? We may want to print patient information out. We may want to do a lot of other things as well. That's just to give you the idea, right? It's data and then functions, known as methods, that use that data. Let's go and play with that idea. Let's go and create a new lecture. I'm going to call it Q2 since my last lecture was called Q mistakenly. New project, Java application, lecture Q2. I'm going to remove the package declaration from it. Do the same things I always do. Okay. I'm going to make a rat class. This is actually almost taken directly from the book, but we're going to do it on our own, rather than just look at slides. So, class rat. These are lab rats. Each one has an age in days. We Could give them names. But you don't name your experimental animals or else you get too attached to them, right? Each one has a weight in grams. I don't know why I'm making these variable names so long. Let's say each one starts off as a baby at 1 gram. And each one has a growth rate, expressed as a percentage, right? Grows 5% each time it grows. So since that's got a fractional value, it needs to be a double. And just for funsies, let's give them names. That ought to be a name, a string. All right. We're going to make 2 methods. One called grow, which adds a day and increases its weight by the growth rate, and then another one called display. So we need 2 methods. Neither one of them need to return anything. So void, display, let's do display first. And it's just going to print this information out. System.out.printf parentheses quote rat name equals %s \n end quote comma name. And then system.out.printf parentheses quote %s weighs %.2 f grams. \n end quote. So we got to fill in this placeholder with name, and we got to fill in this placeholder with the weight in grams, weight grams. And I'm just going to copy and paste that to speed things up, and I'm going to print out its age in days. So %s age is %d days. Why d? Because it's an integer. Oh, I made its weight in grams an int, which is not right? Because if it grows 0.5%, the next day it might weigh, 1.05. So I need to change this thing. That needs to be a double. All right. And so there we go. Age days. I guess we're not printing out its growth rate. We might want to. How about rat name equals %s, comma, growth rate equals %.2 f. And then so after the name we need to put comma growth rate. Now there's something I could be typing to help me pick from lists of these variables. Instead of growth rate, I could have typed this dot growth rate, and I would have been able to pick from the list. And I should have been doing that all along, but I didn't. This dot name, and when I say should have, it's just what I prefer. This dot name, this dot weight in grams. This dot name and this dot age in days. Excuse me for reformatting. All right. So that's our rat class. Maybe we'll call it lab rat just for fun. I'm going to come up here and call it a lab rat. Alrighty, so down here in main, or do I need to slow down? Let's build it and make sure there's no syntax errors in it first. Maybe we should be good programmers and for once put this in its own file. If I was going to do that, I would cut the entire class I would go over to projects, and parallel to my lecture q2.java, I would right click on default package, do new Java class, call it labrat, and then paste my class in it. But I'm going to have to add the word public to it. All right. So that's my labrat class. This is main, which doesn't do anything yet. And it's giving me fits about getting them back to where they were before. All right. Anybody need typing time, or are we good to go?
Yeah, anytime.
All right. So how do you make a rat? Down in main, you're going to add something like this. Labrat R1 equals new labrat, parentheses in parentheses. And you could make as many of them as you wanted. And then if you wanted to give it a name, you could do something like R1.name equals, Rudolph. Right. Now I'm going to go down and do that actually in main, just giving you a sneak preview. Additions. So going to main, let's make some rats. Rat R1 equals new rat, parentheses in parentheses. Sorry, it's a labrat. Labrat R1 equals new labrat. Labrat R2 equals new labrat. Let's set R1's and R2's names. R1.name equals Rudolph, whatever names. R2's dot name equals Becky, in parentheses and semicolon, or in parentheses semicolon. Now let's age each one of them. Well, we haven't even written an age function, but we wrote a display function. So let's display our rats. R1.display, parentheses in parentheses. R2.display, parentheses in parentheses. So when I run it, hopefully it'll display our rat information. Rudolph has a growth rate of 0.5, weighs 1 gram, and is 0 days old. Becky's information is the same because nothing changed it. Let's change their growth rates. Rudolph grows faster. So R1.name, or excuse me, R1.growth rate equals 0. He grows 15% a day. I forgot my equal sign. And R2.growth rate, I can't type, where's there, equals 0.10. Now really, I don't think growth rates work like that, right? I think you start off growing an awful lot, and then as time goes by, your growth rate slows down rather than increasing exponentially, but that's all right. So now when I run it, we should see Rudolph has a higher growth rate than Becky. But we haven't written our grow function yet. That'll be the next thing we do, because we want to be able to do something like this, right? R1.grow, parentheses in parentheses, and R2.grow. That's what we want to be able to do. And maybe we might even want to be able to specify a number of days. I might be able to type R1.grow, parentheses 10, for it to grow 10 days. Maybe I should call it age.age, right? It's getting older. I'm going to call it grow, though. Okay, so let's go up. Let's go over to our LabRat class and add a grow method. What's grow going to do? It's going to add 1 to the days, and it's going to increase its weight in grams by the %. So void grow, parentheses in parentheses, curly brace. This dot age plus plus, just grow 1 day. Sorry, it's not called age, is it? This dot age days plus plus. And then this dot weight grams times equals parentheses 1 plus this dot growth rate. Right, because if it's 0.05, that's supposed to be 105%. So 1 plus 0.05, multiply that by its former weight. Let's compile it, make sure it builds. And we may as well be adding some comments. So, age the rat 1 day, increasing age and weight. That's what that does. Display the rat's vital statistics. All right, I'm going to run it, but I haven't added any grow calls to the grow method yet, so it's not going to get any older. Why don't we put a print message here saying what we're doing, right? System.out.println this.name plus quote is 1 day older, exclamation mark, end quote, in parentheses, semicolon. All right, I'm going to flip back to main so that I can call the grow method on each rat. R1.grow, parentheses in parentheses, R1.grow, parentheses in parentheses, R1.grow, parentheses in parentheses. And let's do the same thing for R2. Copy those 3 lines and paste them. That's why I get ahead of some of y'all, as I'm way more dedicated to copying and pasting than some people. Here we go. And then let's display them again. So just copy those 2 lines, the dot displays, and paste them again. All right, let's see what it does. The rats get 3 days old. Since Rudolph has a higher growth rate, he weighs 1.52 grams, while Becky weighs 1.33 grams after 3 days. Now what if I wanted to be able to specify how many days old I wanted it to get? Like grow 10 days. I could do that, but I better pause. I want to make sure nobody has syntax errors. Anybody need to see this line, this page on main any longer? All right, anybody need to see the lab rat class any longer? Nobody's speaking. All right, so what I would really like to be able to do is instead of having to call grow 3 times in a row, is just call it once and say, yo, grow 3 days. But that broke my code. The reason why is the grow method is not defined to accept an integer as a parameter. So I'm going to have to go and modify my grow method. And what do you usually do if you have something that's going to be repetitive? Grow 3 days, you're going to add a loop to it. So we're going to go and modify our grow method like this. Int days. The comment is now wrong. Age the rat. How about I can't think of a way to reword it, so I'm just going to do that. Age the rat, increasing the age and weight. And this needs to be inside a loop, right? If they say, you know, one day, we need to execute it once, and there's always more than one way to write a loop. But how about this? While days is greater than 0, in parentheses, open brace, tab these things over, and then do days minus minus, and then a closing brace. Right. So if we pass in 10, you know, we're going to age it 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 while the days counter goes down. Alrighty, so same results it looks like, which is comforting, right? Becky weighs 1.33, Rudolph grows 1.5. So you could look at the code in the PowerPoint. It's pretty similar to this. There's a few changes. One thing they changed is they made some of this data private, or they may have made all the data private. Private means that it can't be changed from the calling code. If I made the name variable private, I wouldn't be able to change its name. If I made the growth rate variable private, I wouldn't be able to change that. So I don't feel like making those changes. But maybe weight in grams and growth rate, I'm not supposed to be able to change those, right? So I'm going to make those private. And I'm going to make the other two public, just to explicitly note the difference. It defaults to something pretty close to public. But if you specify it as being public, it leaves no question. So if in my code over in main I did r1 dot growth rate, well, that's going to be a syntax error now. I should not have made that variable private. If I go back to main, I'm going to see it's listing that as an error. So that was a mistake. Let's come back here and make that one public. And age days private. Now one rule of thumb is to make all of your data private. And we didn't do that. If you're going to make your data private, you might want to put setters in your code. Setters to set the name. Once you start doing that, your code starts looking, you know, the class gets a little bit longer, and I'm willing to forego that this time. But I'll show you what it would look like, because I want to show you how easy it is to add setters to code if you cheat and let NetBeans do it for you. If I highlighted those lines and did refactor encapsulate fields, and I said that I wanted getters and setters for everything, here's what they look like. I'm going to undo this change, by the way. But get growth rate, all it does is return the growth rate. Set weight grams, it just sets this dot weight grams equal to the value that's passed in, and so on. So since it's so easy to add getters and setters, I ought to go ahead and just have y'all do it. But like I said, I'm going to undo it because I want the code at this point to not show the getters and setters, even though it's considered good programming to add your getters and setters. That's known as data encapsulation. And the reason you do that is so that you can guarantee that the data is good data. You try to make the compiler help yourself from making mistakes. It would be a mistake if our code accidentally changed the growth rate to 0, perhaps, right? And so by making the data private, we would not be able to change the growth rate to 0 or a negative growth rate, right? But then we might need a setter in order to allow it to set the growth rate, and the setter could check. Are you trying to set it to a value less than 0? Well, that's an error. Our growth rate's not, our rat's not going to be shrinking. Are we all good on our typing? You can have methods with the same name that you can have multiple methods with the same names as long as they have different parameter lists. We could have had a method called grow that didn't accept any parameters, and we could have had another method called grow that did accept parameters. Or you could use default values in this case to accommodate the same idea. Like if we said that if you call grow with no arguments, days defaults to 1. Is that just a flat out error? Oh, you can't do that. No default values for variables in Java? Not JavaScript, Java. Nope. All right, never mind. Can't assign default values in this language, unlike a great many others, including Python, C, C++, C#. So we go and look at our PowerPoint. If you declare something as public, then that means that main can change it. If you declare something as private, then main cannot change it. And see, their code looks very similar. They're calling .grow and then they're calling display. We could go and look at their code. So when you create a variable, we called ours labrat, they called theirs mouse. Labrat R1, mouse Gus. This is called a variable. It's called a reference variable because it's referring to an object. You could then have 2 references to the same object if you wanted to, and this is usually not what you want to do. But if I go in here and did R3 equals R2 well, I don't have an R3 yet, right? Labrat R3 equals R2 semicolon. Now I have 2 names pointing to the same object, pointing to the same address in memory. Just like you have 2 street signs pointing to the same house, doesn't matter which street sign you follow, you're going to get to the same house. If you, I have 2 names, right? You know, you could call me Jeff or Professor Thompson. If you go and kick me in the knee, then both of those people have had their knees kicked. So if we say r3.grow, parentheses in parentheses, and then r2.display, we're going to see that, oh, sorry, we have to specify a number of days, don't we? We're going to grow this rat for 100 days. All right. And so Becky growed a heck of a lot, and then when we called r2.display, we see that this rat that was referenced by the R2 variable is much heavier and is much older. Even though we called it by R2, right? We didn't do R3.display, we did R2.display. So these changes that were made to that object happens regardless of whether we call it by R3 or R2. This does not copy the object. It does not take rat number 2 and make a new rat called number 3. Instead, it just creates two references to the same memory. And that's kind of subtle, but I hope it makes sense. I really hope that makes sense. Does that make sense? All right, good. The this reference. What you do with that is you use it inside inside a class to indicate that the variable that you're referring to is part of that class. So over in my lab rat class, age days is a member of this class. If you have a variable that's declared locally, like this, int x, don't add this because it's stupid. I can't then say this dot x equals 3. Why? Because x is not a member of the class. If I wanted it to be part of the class, I'd cut it and I'd paste it up here. So this is a local variable. These are instance variables. They're called instance variables because they can change on an instance by instance basis, meaning that each object can have its own name and age and weight and growth rate. That's why we were able to have 2 rats. We gave it a whole bunch of instance variables. So default values, and we did take advantage of this. When you create a variable, a local variable in Python like this, if I did int x, it doesn't have a value, and it would give me an error if I tried to do math, right? If I tried to do that, it's going to underline that. It's going to say variable x might not have been initialized. Well, yeah, no kidding. It's right there, and it's not initialized. However, if you declare a variable as a member of the class, it does get a value. It gets a value of 0. That's just the value. Everything gets a value of 0, or if it's a Boolean variable, false, because false means 0. If it's a reference type, a class name, it gets instead a value of null, but again, that's just a kind of 0. So the default values for instance variables or for class members are zeros or variants of that. But you can give them your own default values, which is what we did here. Every rat that's created is 0 days old, weighs 1 gram, and has a growth rate of that. So, yeah, there we go. This is like an exam question kind of stuff. Integers get the default value of 0. Floats and doubles get 0.0. Booleans default to false. Reference types, which is just a class, labrat is a class, so that means it's a reference type. String is a reference type, gets set to null. Null is not a good thing. What do I mean by that? If I tried to print out the thing's name without having given it a name, it's going to print out null instead, which is going to look stupid. And if we tried to access any of the methods that the string can support, it would crash the program. So, if I was smarty, I would have given him a default value. Or even default, right? Or labrat, right? Something like that. Just so that if I try to access that variable before somebody has said its name, it won't crash the program because it'll have valid data in it. Now that change I'm not going to undo. So variable persistence, that's how long it exists before it's wiped out. If I create a variable here, like string, don't do this, I'm going to wind up deleting it most likely. All right, you can if you want, right? String s is equal to name, or this dot name. You don't have to use the this reference, but it sure does make typing easier, right? This dot name, right? If you have long variable names like weight and grams or whatever, it makes it a lot easier to type. This variable s disappears when we get to the close brace. That's its lifetime, that's its scope. So if I tried to print out s here or do something to it, it's an error. these variables up here don't disappear until the entire object disappears. So these variables can be used by all the methods in the class. So if an object makes two method calls, the second method does not reset the calling object's instance variables to their initialized variables. Instead, the object's instance variables return their values, maintain their values. What does that mean? The first time we call grow, age days increases. So it'd go from 0 to 1 to 2 to 3. The second time we call grow, age days does not get reset, right? It maintains whatever data was, whatever the state was after the last time grow was called. That's how this whole thing works, right? These variables maintain their state between calls to the functions. The data continues to exist after the function call is completed. That's the entire point of objects. If this data did not continue to exist once a function was called, then we wouldn't be able to do multiple functions affecting the same data. Tracing a program. Nah. Tracing the mouse. Nah. A UML for the mouse. A UML diagram shows what the mouse consists of. In our case, it'd be a lab rat. The UML for our lab rat would have several variables, more than NERS has, actually. It would look like this. The first box is the name of the class. The second box is a list of variables, and if they have minus signs, it means that they are private, and if they have plus signs, it means that they're public. So our lab rat had a name, not a Bane, a name which was a string. Our lab rat had a age, which was private, age in days, which was an int, and it had a weight in grams, which was a double, and then it had a growth rate. What type was our growth rate? Double, yeah, all right. And then in the third box of the UML diagram, stands for Universal Modeling Language, I believe. Now, I didn't stick the word public in front of them, and I should have. If you make your methods private, then main cannot call them. So I should go back to my code and make my methods public. That's a rule of thumb. Data private, methods public. But like I said, if you leave it off, it defaults to something very close to public. Unlike C++, which is the opposite. If you leave it off, it defaults to private. Okay, so we had two methods. One called grow, which took a variable called days, which was an int, and grow doesn't return anything. So you could leave the stuff after that blank, or you could put colon void. I've seen textbooks go both ways. I'm going to put colon void. That's what our textbook does, and that's my preferred method. And then there was another one called display. Does display take an argument? Does it have any parameter variables? Nah. Okay. That's the UML for our lab rat class. So for homework, I could give you a UML and ask you to implement it. Like a sphere. And a sphere has one variable in it. It's got a radius, which is double, and we're going to make it public. And the sphere is going to have several methods. Get diameter, which returns a double. Just to add a comment. That's 2 times the radius. It's got another one called get volume, which also returns a double. And I believe that's 4.0 divided by 3.0 times radius to the power of 3, right? And then one called get area, or surface area. And I believe the formula for that is 4 times, oh, I forgot pi here. 4 times pi times radius cubed, and this would have been 4 times pi times radius. Let's make sure that that's formula correct. Yep. Times radius squared. All right, that's our UML for sphere. I could ask you to write that as homework and then write a main method that would, utilize that class. Their UML diagram shows a little bit more. It shows that there's a file called mouse2driver with a main method, right? The main method uses these variables. It has a scanner, and it creates a mouse named Mickey, and it has a days called int. And then the mouse2 object is of this type. And in some UML diagrams, there'd be a dotted line, or something like that going from here to here, showing that there's a connection between that variable and that. This one, for some reason, isn't showing that. Now, I'm not going to make you draw all these little boxes, right? But I do want you to know how to create this part of the UML based on the class. So local variable is one that's declared inside the method. It only exists while it's inside those pair of curly braces. It's called local because it's only accessible inside the curly braces in which it's declared. Local variables don't get default values. So if I did for int I, but I didn't give it a equals 0, then this code wouldn't work. It would not compile. It would say I was uninitialized. Now, I don't know why they don't make all variables default to 0, honestly. So that is their persistence. This local variable's persistence is only for here to here. After that is done executing, we cannot print out the value of I or do anything else with it once the closed curly brace is encountered in the code. So the return statement allows us to pass a value from a method back to the place where the method was called. So for example, we're going to make another little class, and it may be about the last thing we do today. And I'm going to just add this one to Q2. So it's going to be a square class. Tell me if I did a square already in the last lecture. Square. Not void square, class square. And a square just has one variable, a side length. So private int side. If it's private, we have to have something that'll set its side. So public space void space set side parentheses, and it needs a parameter. It needs a value to set that to. Int space side in parentheses. And so its code is this dot side equals side. So the this dot tells it that this variable is that one. And if you leave this off, it assumes that you're referring to that one. Now let's write the get area. The surface area of a square is just the side cubed multiplied by 6, right? No, wait, that's a cube. That's not a square. So it's just a side squared, right? But it needs to return a value, so it's not going to be void. Public int get area, parentheses in parentheses, and it's going to return, or let's do it 2 steps. Let's calculate it and return it. Int area equals And by the way, when you do that sphere class, make everything a double, not int. And as a matter of fact, I should have made these doubles as well. Let's do that. Change all these to doubles. Because we might want a square that has a side length of 2.5. Right? So the area is just equal to this dot side times this dot side. Or we could say math with a capital M dot POW side comma 2, or this dot side comma 2. You don't have to use the this reference unless you're in a situation where there are two variables with the same names. And in our setter, we do. So this is known as a setter. The technical name that the book calls it is a mutator. Mutate like change, like x-rays mutate your genes, right? So setter, I mean hopefully not too badly, but anyways. Like that. So this method calculates and returns a value. I forgot to add the return keyword, so it's telling me that I've made a mistake. Since I have a return type defined, I better return something. Whatever you return had better be compatible with its return type. Like if this had been declared as int, which it was originally, then trying to return a double in this language, unlike C++, is a syntax error. In C++, it'd go ahead and return it would just return it as an int, and you'd lose some data. So our class, our code, could create some squares and calculate their areas. So down in here in main, square S1 equals new square, parentheses in parentheses, S1 dot side equals 10. Whoops, we can't do that. Why is that an error? Yeah, sure, I can move my mouse over here and it would tell me. But what's the problem? What have I been talking about public and private? Which kind of variable is side?
Private.
It's private, so it can't be changed down here in main. In the client code, the driver code is what the book calls it.
Set side.
So we've got to call set side. Exactly. S1 dot set side to 10, to 19, to whatever. And then we could print out the area of square 1, right? System.out.println, parentheses quote, area of S1 equals space end quote plus S1.get area, parentheses in parentheses in parentheses semicolon. So if it's got a side of 10, its area is going to be 10 times 10, which is 100. So when I run it, that's what I'm expecting to see at the top of my program. Way up here. Yep, that's its area. Working for folks. The only reason I get up and walk around is to look at your keyboard because it's so cool. After it would be all right, good deal. Good deal. How's your phone?
I think I need to back it, that's all. Yeah.
Yeah. Okay. Cool deal.
Something's going on with my keyboard. I'm having to retype all of this. I continue. Just started randomly giving me that line.
Let's finish this one. I just typed it in this one time. That probably means that we're missing a close brace somewhere. What? I messed it up. Open and close and close. Semicolon.
But
All
it's
right.
deleting all of this. Every time I hit enter, it deletes a line.
Oh, really? That's what you were telling me.
Yeah.
So like if I do that, well, no, it's not.
And that's not good.
Sometimes they get into overstrike mode, where, like if it's in overstrike mode, then when you come back and you start typing, it replaces it
Yeah.
like that, and that's what it's doing. That's when the insert key has been pressed. So you press insert again, and it
Okay.
goes out of overstrike mode.
Okay. That's
Yeah.
probably what happened.
Population error's gone? I mean, it's still not running because of the display problem, but. All right, so we've written a couple classes. We've written the lab rat class, which is extraordinarily similar to the mouse class. Ooh, I didn't pause it. Oh well, we're all here. We've written the square class. We've got the UML for the lab rat class. Here is our UML for our sphere. So our homework. Write a class that matches the UML diagram below. The main method should create two spheres with different radiuses and print the diameter, volume, and surface area of each one. And I'm not expecting you to type that UML in. I'll just upload it. That'd be the homework. Notice that this radius is not private, unlike the side was in the square. If you felt like it, you could make radius private, and then you could add a method called setRadius. That's only if you want. All right. Make sense, gang?
Mm-hmm.
All righty. Hit the drop box and be done.